know how to do this. That's awesome. I've taken off all of the skipping prevention. You can go look at the parts that you want to. This is purely for your review to help those of you that are still struggling with graphing a line to master that skill. So here we go. We're going to graph a line. You could be presented a line in standard form, which is ax plus by equals c. You have three options. First, you could find the y-intercept and use the slope. That's a very convenient one. Second, you could find the x-intercept and use that very same slope. It's another convenient one. And third, you could find the x and y intercepts. Again, another convenient one. The second form of an equation that you could be given is slope-intercept. That's y equals mx plus b. And you could use the y-intercept and the slope, m. Or what a lot of people don't realize is that you could also pick up the x-intercept. Say it's like not so far away from the origin, like maybe your y-intercept is like 0, -25, but your x-intercept is 0, 5. You could use the x-intercept and the slope. Let's do a couple of these. I'm just going to vary the techniques through all 5 options. This I'm going to use option 1, x minus y equals 5. I'm going to find my y-intercept, which is 0, -5. I plug in a 0, I solve for y. Negative y equals 5, so that means y has to equal -5. Then my slope, I'm going to use the opposite of coefficient a over b, and that gives me -1 over -1, which is +1. Now I'm going to graph my y-intercept here, and I'm going to use my slope to get points on the line. The reason I'm using x's instead of dots is that it is somewhat easier for me to do that. And that is the graph right there. Now I'm going to graph the line x plus 2y equals 4. Notice that x has a coefficient of 1. It's easy for me to find the x-intercept. I plug in a 0 for y, so x plus 0 equals -4. So my x-intercept has to be -4, 0. Then I'm going to use my slope. Again, I'm going to use the opposite of coefficient a over b. That's going to give me -1 over 2. So I'm going to graph -4, 0. That's here. Well, that worked pretty good. And then I'm going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. The reason I didn't go up 1 over 2 is that I was already close to the edge of my graph. So it looks like that. On this one, I think I'm going to use both my x and y intercept. So I'm going to plug in 0 for y. So 3x equals -6. X equals -2. That's the point -2, 0 right here. Then I'm going to do -2y equals -6. Notice that I picked up that 2 right there. And then y equals 3, so this is the point 0, 3. And I'm going to connect those two dots with a line, call it a day. On this one, I'm in slope-intercept form, y equals mx plus b, and I'm going to use my y-intercept, which is 0, -4. Because again, I plugged in a 0 for x. That left y equals 4. And then my slope is equal to 2. So my y-intercept is down here, 1, 2, 3, 4. And then I'm going to go up 2 over 1. And 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 I'm going to connect it with a line, just like that. Okay, it's probably easier for you to use dots and X's. Please do so. All right, this one I want to show you that you would think, oh, I'm just going to use the y-intercept and the slope, and you definitely could. But I want to show you that the y-intercept is 0, -10. But look, my graph only goes to -5. So if I found the x-intercept by plugging in a y for 0, I get 2x minus 10 equals 0, 2x equals 10, x equals 5, and I have a much closer x-intercept. So here I am at 5, 0. And then I'm going to use my slope, which is 2 over 1. I don't have any room to go up, so I'm going to go down, down 2, 1 to the left, down 2, 1 to the left, and I'm going to connect it like that. And this one is going to go off like that. I'm done. Now we're going to move on to inequalities. That screen is intentionally left blank. All right, so it forms right out of graphing a line. You want to look at your inequality, and you want to look at the symbols, the inequality symbols, and decide if your boundary line is dashed or solid. So for symbols greater than, less than, no equal part, dashed. For symbols that include the endpoint or inclusive, greater than equal to, less than equal to, use a solid line. You're going to graph the boundary just like we used any of the techniques in the previous slides. You're going to test a point. Always test a point that's not on the boundary line. Not on the boundary line. If you can, use 0, 0. Once you test it by plugging it into the original inequality, if it's true, if the inequality is true, then shade toward the point. If the point produces a false inequality, then shade away from the point. So I'm going to use some of the examples that we had. I already have the lines graphed. Notice on this particular one, I changed the inequalities, the equal sign, to a greater than, so I have to use dashed line. And notice that I changed my line to dashed. All right, and now same information as before. I put it on there for you, but here's the line. Now we have to test it. I'm going to test 0, 0. Is 0 minus 0 greater than 5? Is 0 greater than 5? Well, that's false. So I'm going to shade away. Away is going to be down here on the opposite side. The second inequality, I used an example that we previously did. This inequality symbol has the equal part to it, so I'm going to use a solid line. I have that drawn. This is the information that I used to draw it. Now I'm going to test a point. I'm going to test 0, 0. Is 0 plus 0 greater than or equal to -4? Is 0 greater than or equal to -4? Well, that's true. So I'm going to shade toward. I'm going to shade toward 0, 0. Or on the same side as 0, 0. Just like that. Last one. I have y is less than 2x minus 10. I use the x-intercept 5, 0, the slope 2. I made a dashed line because of my inequality symbol. I'm going to test the point 0, 0 because it's not on the line. Is 0 less than 0 minus 10? Is 0 less than -10? That's false. So I'm going to shade away. Just like that. All right.